straight constants obey the Arrhenius equation. The Arrhenius equation follows a couple of very simple principles. The collision must have enough energy to produce a reaction. Therefore, it must be equal to or greater than the activation energy. And second, the molecular orientation must allow for new bond formation. When it comes up with a reaction, they need to have enough kinetic energy greater than or equal to the activation energy. And second, they must have the correct orientation in space for that reaction to take place. From these two principles, they came up with this equation: K is equal to Zp e raised to the Ea, which is activation energy, divided by RT. R is everyone's favorite number. Z is the collision frequency, and P is called the steric frequency. So the collision frequency, how often do these things collide? And P, the steric frequency, how often are those collisions of the correct molecular orientation to where a bond is going to take place. So these two factors were simplified, or these two letters were simplified into a single constant called A, which is just called the frequency factor. And this is Arrhenius' equation. Often it'll be written like this, where they'll take the natural log of both sides. Natural log of K is equal to minus activation energy over R times 1 over T plus natural log of A. And from this, often people will rearrange it even more in order to make it simple to get activation energies. So what they've done here is just subtracted this equation from a second equation of equal value. Well, not equal value, but just this would be K1, K2, and then these are both the same, and then T2 would be the only difference between the two. So they would subtract these equations, and what this does is it makes it simple to determine what the activation energy is. What people will do is they'll set up an experiment. They'll determine the rate at one temperature, K1, they'll find what temperature that is at, and then they'll take a second temperature, find out that rate, and then from there, if I have both of these pieces of information, K2 over K1 and then 1 over T1 minus 1 over T2, then I can figure out the activation energy, because everyone already knows what R is.